with that, let me jump and pivot us to our next panel. We've got an incredible opportunity to talk about, we're going to shift from space, the final frontier. We're going to move to our inland waterways and Great Lakes. So I want to just make sure that Dr. Craig Phillip is with us. I got to quickly shuffle my deck here to make sure I've got, there he is. So Dr. Phillip, I want to make sure that you are with us. Is that the case? I just need to.
Yes, sir. Good morning.
Great. Good to have you. So I'll introduce you quickly there, Dr. Phillip, and he is actually the research professor of civil and environmental engineering at Vanderbilt University, and actually the director of Vanderbilt's Transportation Center, Vector. So I appreciate somebody from truly the heartland in Tennessee talking about the Great Lakes, and I obviously know that you've connected them through the inland waterways, which most people don't realize what an incredible system that is. So I will not take any more of your time. I'll let you introduce your video, and obviously when the time comes to introduce your panel. But exciting things to hear, and then obviously questions to be put in the chat box or raise your hand afterwards. But Doctor, I'll turn it over to you, sir.
Well, thank you very much, and good morning, Admiral Parks. It's delightful to be with you all, and I think without further ado, we can move to the video of our presentations from our three panelists, and look forward to the Q&A at the end, and hope everyone will be hard on my panel colleagues. Well, good morning, everyone, and welcome to this panel, which will focus on the inland portion of the maritime domain. I'm delighted to be with you today. I'm a member of the Marine Board, which is one of the sponsors of this conference. Inland networks differ in many ways from other maritime systems, but particularly when viewed through a resilience lens. Two key characteristics stand out. First, inland systems are often characterized by a linear topography, and they often exhibit a non-redundant functionality. And second, in the United States, ownership and management is both centralized and decentralized. Ownership and management of the infrastructure, the locks, dams, dikes, and levees, is by and large the responsibility of one federal agency, the U.S. Army Corps of Engineers, with some involvement by quasi-governmental agencies like the Tennessee Valley Authority in some regions. Meanwhile, the ownership and operation of the ports and terminals are often decentralized and privately managed, with some ports simply being a collection of independent terminals and other facilities. You'll hear about implications of this intersection this morning. This panel will engage with three prominent researchers who have been deeply involved in recent projects that have explored various aspects of inland maritime systems resilience. The first will look at inland resilience in the context of a broad examination of supply chain disruptions. The second will compare resilience analysis approaches that have been applied to maritime systems around the world. And the final contributor will look specifically at the Illinois waterway, and particularly issues of modal competitiveness. I'm going to introduce all three at this time, and then we'll move directly to their presentations and then remarks. Dr. Michael Meyer is today a strategic advisor with WSP Inc., and has a distinguished career both as an academic, most recently at Georgia Tech, and through several roles in state government. He's a prolific author and thought leader, with much of his recent work focused on transportation system resilience across the modes. I was privileged to connect with Mike many years ago, more than either of us will likely admit, when we were grad students together at MIT, where we were part of a powerhouse intramural softball team together. Mike will share insights from his leadership of the 2019 TRB-sponsored research project, Freight Transportation Resilience in Response to Supply Chain Disruptions. Mike will be followed by Catherine Chambers, who is a research physical scientist with the Coastal and Hydraulics Laboratory section of the U.S. Army Engineer Research and Development Center. We know it as ERDC. Best I can determine, Catherine is involved in just about everything the Corps does that involves resilience, and co-leads an intra-agency team entitled the Resilience Integrated Action Team, working as part of the Committee on Marine Transportation. She will draw on work of a PIANC study, Resilience of the Maritime and Inland Waterborne Transport System, that she chaired and that published its work in 2020. And it includes numerous inland waterways case studies from around the world. Finally, batting cleanup will be Dr. Mark Burton, who is Interim Director of Marshall University's Appalachian Transportation Institute. Prior to joining Marshall earlier this year, Mark was part of the University of Tennessee's Transportation Research Center. He will look in detail at the Illinois waterway and the resilience issues that cut across the freight modes. So before turning it over to our panelists, let me make one final observation. We are fortunate to pull together three very different perspectives this morning, and it includes three different disciplines. Mike is a civil engineer, Catherine is trained as an ecological scientist, and Mark is an economist. When it comes to dealing with issues of resilience, we need them all. Mike, it's all yours.
Thank you, Craig. And I do also affectionately remember our championship softball team at MIT. And I believe I was so bad that the captain put me in as team mascot because I really wasn't a very good softball player, but it was a good experience. As Craig mentioned, I'm going to talk about a project that was completed last year by the National Cooperative Freight Research Program of the Transportation Research Board that looks specifically at disruptions to the supply chain and really intended to do three things. One was to better understand the characteristics of those disruptions, to look at some tools, analysis tools that could be used to kind of predict what the results of those disruptions would be in terms of flows in particular. And then finally, and most importantly, develop a guidebook that could be used by both public agencies as well as private firms to enhance what we call organizational resilience capability, i.e. what is it you need to do as part of an organization, whether public or private, to look at resilience in a very systematic and comprehensive way. At the beginning, though, let me start with some definitions. These are the definitions that were part of this research. The resilience definition is fairly typical that one sees in the literature across all fields. It's really, it's a system that can absorb, recover from, and then adapt to adverse events. What this project did was then looked at what does it mean to be a resilience-oriented agency, which in essence is the ability of an organization to prepare for, plan for, manage, and then recover from expected disruptions. And then a resilience program, of course, are those actions, strategies, and efforts that collectively can lead to a more resilient transportation system. So these definitions, if you will, were kind of the point of departure for the research and for the recommendations that came out of the project. In terms of the characteristics of the disruptions, we were looking at all types of commodities. We were looking at all types of modes of transportation. And quite frankly, we were also looking at different characteristics of disruptions, which you'll see in a minute. So we identified kind of three major types of disruptions: those that are abrupt, that happen and people didn't expect them and certainly didn't plan for them; rapid events that occur with a little bit of advance or notification, such as a hurricane, for example. It's coming 3 or 4 days from now; and then planned and predictable events, things like you're going to be redoing locks or you're going to be redoing a major highway, and it's planned for years in advance, so you can actually put in place strategies to minimize the disruption of that particular project. Also, with regard to the disruptions, there are different levels of loss, severe impact that could have both national and international impacts with regard to economic costs. What we would call the high impact, that was primarily more regional and national in nature, and certainly still had a very high economic cost, but it was more localized, if you will, to parts of a country, such as a major hurricane that would physically impact a certain portion of the country, would certainly have reverberations throughout the economy, but was very much focused on one particular region of the nation. And then low impact types of losses that are really more very specific to a metropolitan area, to a city or a locality or a specific site, that would certainly have costs associated with it to both the freight and the public sectors, but generally not as significant as a major significant or severe impact such as COVID, for example, which one argue would probably global now, so in terms of the impact. The geographic scope was also important, primarily because it really dictated who would be involved, especially from the public sector, where all public agencies are very much specific to jurisdictional boundaries. And so you have everything from international scope of international implications with regard to the supply chain and which stakeholders in the supply chain would be involved, all the way down to the local level, where again, you may be involved with specific detours of routes around a particular disrupted facility, for example, which gets involved with local agencies, enforcement agencies, transportation agencies, and obviously those who are involved with the movement of freight at that location as well. So that's geographic scale became a very important element of really trying to understand what the impacts were of a particular disruption. In the research, we kind of looked at the different combinations of, what are some examples of disruptions with regard to whether it's low, high, or severe impact, and to what extent could there be planned ahead of issues that would be associated with that, to the abrupt, if you will, disruptions. In the lower left-hand side, you see those that are probably going to have low impact, at least generally speaking, and you can plan ahead for them, such as a lock closure. Not saying that wouldn't have a huge impact economically to some individuals, but generally speaking, across the board, it would be very different than, say, a major earthquake or a tsunami or large-scale military deployments for a major issue, labor strike, weather events that really affect an entire region, such as a nor'easter blizzard, for example. So what we looked at and tried to identify as part of our research were case studies of different types of disruptions in different types of supply chain issues. Now, as I mentioned earlier, we were very interested in kind of looking across the board with regard to the types of modes that we wanted to focus on and the types of disruptions. And so what you see here is that there were 10 different scenarios that we were interested in terms of both mode as well as disruptions. Disruptions, everything from a major failure of an infrastructure to labor strike to technology or an attack on your IT systems, terrorist attack, earthquakes, et cetera. So we were trying to understand the different dynamics associated with different types of disruptions for different types of modes, freight modes in particular. And I can't go into great detail given the time, but each one of these became the focus of a case study where we interviewed, all the stakeholders involved with that particular mode, as well as those that would be involved with the disruption response. We identified different factors that are important when looking at system resiliency and both response and kind of the long-term planning for a more systematic and resilient transportation system. These are those I'm sure you are familiar with, obviously the physical infrastructure associated with the actual infrastructure that's associated with the movement of freight and passengers, all the way to the institutional framework that looks at both corporate policies, the interaction with governmental agencies in terms of how you respond to events, and again, how you put in place a system to prepare for and develop a more resilient transportation system over time. And then you can see in between things like the communications, transactional support systems, et cetera. So all of these became an important part of what we were looking at, specifically with regard to the types of strategies that could come out the other end with regard to how to enhance system resilience overall. Just as one example of our case study, and again, I won't go through all of them, but this was a case study of the supply of grain from northern Illinois to southern Louisiana, obviously by barge in this particular case. And what we were looking at was a base case, which in this case, the best data we had was from 2007. And we used the model to kind of analyze what was going on in that particular movement of grain. And what you can see up at the top is the base case that by far the vast majority of the tons were moved by water or inland water system. There was some truck, but there was some rail. We then introduced in the model a disruption, and that could be a river closure or restrictions of movement of barges because of low or high water, or because a particular lock was out because of maintenance or failures. And then at the bottom, we looked at, well, from the modeling perspective, what would likely happen if, in fact, that disruption occurred. And as you can see, not unexpectedly, a large percentage of the movement of grain would go to rail, and some percent would go to truck. And so, again, we were trying to illustrate how one could look at, from an analytical perspective, the impact of disruptions in other modes of transportation for the different modes that we did in our scenarios. I think one of the major contributions of this research was really looking at kind of the organizational capability as it relates to resilience, of how do you prepare your organization for better handling resilience issues, both from a disruption perspective, short-term disruption, but importantly over time, enhancing the capability of your organization, staff-wise, training-wise, tool-wise. And so we developed a 7-step process, which we argued really was a framework of thinking of how you incorporate resilience into your agency or an organization, everything from how do you organize for success, how do you develop a communication strategy and a plan for communicating both internally as well as to external stakeholders, all the way down to then once you have this in place, how do you monitor system performance, in this case, transportation system performance, to see if in fact you are enhancing the resilience of that system. And each one of these steps had a kind of a self-assessment approach that the agency could use to see where you are currently and what it is that you could do to implement strategies to enhance your resilience capability. Now, I just have one example from step 3 of that framework, which was to assess current practice. And this is called a capability maturity model, which is basically a self-assessment process, which looks at answering specific questions as it relates to this particular step. So, internal to your organization, question 1 is, have you assessed how your agency is doing with respect to enhancing the resilience of supply chains and transportation systems? And those are the types of questions relating to internal. And then also we identified those that relate to external relationships to your organization. Then what you see at the bottom is we very simply assign points, whether you say yes or no. And if you fall in the 8 to 10 range of the answers being yes, then the assessment is that you've done a pretty good job of looking at this particular step of that resilience framework. And what you need to do is just to continue doing more of that and to continually monitor that you're doing these types of activities. If, however, you fall in the 0 to 4 range, that says, you know what, you really need to do a better job. And there are some strategies that you can use to try to incorporate more of a resilience orientation into your activities in your agency. And that basically then follows into specific steps, which is if your agency had a strategy, or in this case, if you fell in the 0 to 4 point range on that previous framework, here are some of the types of strategies we would suggest that you undertake. And there are a lot more. Obviously, I couldn't put all of them on the slide. But for example, the third one, examine past supply chain transportation systems disruptions to see where, in fact, improvements to your capacity could be made. In other words, learn lessons from what's happened in the past. Now, I'm not saying that folks haven't done this already. Certainly major corporations have done a lot of self-assessment in terms of how to keep their business continuity planning, et cetera. But I'm simply saying that if you're at the low end of that assessment, these are some of the things that you may want to think about if you're not doing them already. If you fall on that middle range, which we said is you're actually well positioned, you're doing more than what an organization would be doing if you were in the low range, but there are certain things that you can do to still improve activities of your agency and organization with regard to resilience. We suggest specific actions here. For example, update your process protocols and standards to reflect changing hazard and market conditions. In other words, try to understand where future threats to your system or supply chain could come from, and think about what you can do now and what you may want to do over time to better prepare your agency and your services for that type of disruption. And if you've already done a good job and you're in that 8 to 10 point range, our argument and the strategies that we look at basically are saying, we need to continue to reassess over time. You still need to monitor the performance of your organization to make sure that, in fact, you're doing what you say you're doing. And then look at other steps in the process and see if, in fact, you need to make improvements to those steps as well. And so the research basically provides a guide for folks to look at their organization and see if, in fact, there are steps that they can take to better prepare themselves for both both short-term and long-term. Finally, there were some overall observations that I'd like to leave you with regard to the research, again, looking at supply chain disruptions. There was very much, and a lot of this had to do with interviews with major stakeholders in the supply chain. There was a clear distinction from folks who viewed resilience primarily as an incident response process versus resilience of looking long-term and more systematically. Everybody that we talked to said, yeah, we can respond to incidents pretty good. We've done this before. We've got everything in place. And when the question was, well, how are you preparing for future threats that you may not understand or see, the discussion kind of fell apart. So the whole point of this research was to get people more thinking about that right-hand side of that particular bullet. Folks mentioned, that they do business continuity planning, and so those types of strategies are in place. And investments are being made to protect businesses from the types of risks that they identify. So, our intent was not to say that nothing's being done. Clearly, a lot is being done. But in the context of the first bullet, we think more could be done in kind of the broader long-term perspective. With regard to public agencies and the role of public agencies, we identified some challenges that in the competitive market that we have in the United States, that there are all sorts of rules and regulations and laws of public agency spending tax dollars that could presumably benefit one company versus another. And we heard this a lot from public officials saying we've got to be careful. And so how you coordinate and support disaster preparation and planning needs to be done fairly carefully with regard to those types of constraints. And also with regard to public agencies, it became very clear, and this should not come as a surprise, that agencies are focusing on what they're responsible for. So the highway agencies looks at highways, those that look at other modes look at those, airports look at airports, and trying to get a coordinated response and learning from others with regard to how they responded to particular incidents, or again, more importantly, how they're preparing for the future has been certainly a challenge. It was very clear in talking to folks who had actually gone through some forms of disruptions that the degree of interest in and participation in resilience planning, if you will, was largely driven by what their perception was of what the future hazards could be and what experiences they've had in the past, and obviously the geographic scale of the market. If they're an international, global supply chain type of firm, they're not only interested in what happens in the United States, but what happens elsewhere in the world that could disrupt some portion of the supply chain. To a person, people focused on redundant networks, and the idea of redundancy is being incredibly important to incorporate resilience into the transportation system, and in particular into the supply chain. With regard to public agencies, again, the idea of funding and providing funding and policies that will help not only standardize practices in terms of how you look at resilience, but also making sure that there's flexibility in that funding that, in fact, will be allowed to help expedite recovery from a particular disruption. And then finally, it became very clear in looking at all sorts of supply chains across all modes and all sorts of disruptions that if you really are interested in an interconnected freight resilient system, that often requires fairly complex, some coordination and collaboration among all the actors that are involved in supply chains, including some fairly sophisticated freight management strategies, obviously. So, the bottom line is that this tool, this guidebook, is available. I would certainly encourage those of you who are interested in looking at what you can do for your own agency or organization to think about this more systematically, to get that report and to take a look at it. Thank you.
All right. Hello, everybody. My name is Catherine Chambers. I am a research scientist with ERDIC's Engineer Research and Development Center, like Craig said a little while ago. And I'm here to talk to you guys today about sort of another effort to take a look at what resilience means for the marine transportation system. All right. So just like anything, the first thing you have to do is define resilience, because it is a concept that has been used in so many ways and so many different types of systems. This definition I'm going to give you now is a result of a PIONC task group report that was published earlier this year in May called The Resilience of the Marine and Inland Waterborne Transportation System. So let's get to it. What is resilience? Resilience is this idea that there's 4 stages where you're able to prepare, withstand impacts, absorb them and recover from them. And then eventually you can adapt so that you're better prepared for the next disruption. And it's not necessarily focused so much on what those individual words are or what they mean, but just that they're there in this cycle. And you really need to consider all four of them in order to make your system more resilient. So what does this mean in terms of functionality? What would a resilient system look like? For the marine and inland waterways transportation system, resilience means continuing acceptable operations throughout disruptions so that your system is disturbed minimally. And here's, I love graphs, so here's a graph of functionality over time where you have a system, you're prepared before a disruption, you get disrupted, your system decreases in functionality, and the depth of that decrease is the ability of your system to resist that hazard or whatever it is that disrupted you. You have your recovery period, and then critically, and oftentimes overlooked a little bit, you have this period of adapting or evolving between disturbances so that the next time you get hit, your system is better prepared to absorb those impacts and recover quickly. Now, also, another very complicated system and definition is the marine transportation system, which includes inland waterways. You have the geographic elements of the system, which is from the point of embarkation or debarkation through your navigable waterways to your port, which is supported by a community. Then to the intermodal connections that bring the goods and services to where they need to go, to the point of origin or the end user. You also have all of these other systems that kind of govern how that geographical system works. You have physical systems that are responsible for actually moving the cargo or the people. You have transactional systems that manage procuring, tracking, and distributing cargo. And you have regulatory and oversight systems that are more things like how are you enforcing security, what is your policy and your framework for activities, safety, health, environmental missions, and managing disruptions, which is important for resilience. So you've got this system. It's very complicated. Everyone can agree upon that. You've got physical, transactional, and oversight types of systems. And there's a lot of examples that you can pull from this to kind of illustrate how complicated this all is and how it's very important to think about resilience. So for physical systems, you have ecological things, you have infrastructure, energy. Ecology might be things like ecosystem goods and services or the protected species in the area, the coastal habitat. Infrastructure is, the actual physical infrastructure like locks and dams around the channels, port facilities, intermodal facilities. Energy is, vessel capabilities and the availability of energy. For transactions, you've got operational or logistical transactions like maintenance or emergency response capabilities, supply chain issues, like we've talked about previously. You've got technology, which includes data and new technologies that are emerging. Regulatory and oversight systems include security, like national security and enforcement, cybersecurity. And then you have the government or political oversight, like competing uses, state and federal funding, trade regulations. I mean, there is so much to consider when you're talking about the resilience of this system. And then you've got your disturbances and your stressors. And first, I should say that all of this information is compiled within that TEONC report I described earlier. So if you're interested in this, go check it out because it does a really nice job of not only outlining these components and stressors, but also case studies and examples of where these have been investigated. So disturbances can affect specific types of systems. The physical system, so say for ecological disturbances, you might have invasive species or changing migration patterns. For infrastructure, you've got congestion and competing demands. Energy might be alternative fuels. Some disruptions might be good disruptions for the environment at least, or power disruptions. You might have, for operations, you might have larger vessels or industrial accidents, labor challenges. Technological disruptions can include cyber disruptions and navigation system failures. Security includes terrorism and critical activity. In government, you have political instability and decreases in public funds. This isn't exhaustive, but it is illustrative. And then, on top of all of these things, we really need to consider these two large disruptions, which are climate change and episodic events. They both affect almost every single one of these types of disturbances and stressors and components of the MTS. So moving on a little bit, you also have to define, once you define resilience, you realize that it's become sort of a call to action for a lot of federal funding opportunities, for a lot of communities. They're asking about what is this term and how can we become more resilient. But because this definition is just these four concepts, or at least the agreed upon definition for the Corps of Engineers, figuring out what resilience means can be subjective and applied variably. There's also a whole lot of resilience resources that are available to people when they need them. Mike just described an amazing study by FHWA that, is super useful for figuring out resilience of your supply chain and your organization. There's also planning frameworks. There's interdependency assessments. There's hazard impacts and modeling. There's tools and capabilities that are very specific, like shoaling rates that we can look at in our navigation channels or vessel traffic. There's also plans like the Marine Transportation System Recovery Plan that the Coast Guard requires for captain of the port zones. There's self-assessments that exist that NOAA sponsors. There's toolkits that are more applicable to broad resilience questions, not necessarily ports, but hey, they could be useful, like the Climate Resilience Toolkit, the EPA's or other toolkits by NFWF on coastal resilience. So this is confusing for people who don't think about resilience every day like I do. And we identified that there is a disparity a little bit between these published resources on resilience and then usable, or I guess the bridge between what you can use for your decision making for your own problems that you're defining within your port area. So together with the Cybersecurity and Infrastructure Security Agency, this is actually a project that is funded by that agency and led out of it. They're developing a port and marine transportation system assessment guide, which, similar to FHWA study on supply chain resilience, is to provide a replicable framework for conducting resilience assessments. But we are not trying to create anything new, really. We're trying to pull all of these amazing resources that already exist and point people to them. And additionally, provide additional resources within appendices. So what does this look like? The guide process is simple. From pre-assessment, where you define your problem and you work with your stakeholders, to the designing assessment according to what you need, conducting it, and implementing findings. This is not a groundbreaking thing. It already exists in typical project management frameworks. What we're providing that's new here is a way to organize methods according to key resilience assessment objectives, which we are recommending everyone needs to at least consider to do an accurate and holistic resilience assessment. And I'll talk more about those in a minute. But they are defining functions and characterizing the system, critical infrastructure dependencies, understanding how your system responds to hazards, and then finally figuring out how to develop and evaluate alternatives. So I said one of the biggest goals of this is to organize existing resources that are out there. And the way that we're doing that is compiling all of those resources and identifying whether or not they apply to a single port, a port network, or an inland waterway. So that's the scope. And also whether or not, or how intensive the level of effort is and what you might get out of it. So we are calling this a tiered framework, where tier 1 is the lowest term tier, where it requires the lowest level of relative effort, where you're trying to understand your system and prioritize how the functions work, try to find easy wins, meet your stakeholders, those sorts of things. Tier 2 is figuring out how the system is structured and how it might respond to a hazard or disruption. And Tier 3 is really the ability to compare alternatives and to create a plan or mitigation plan or an adaptation plan to make your system better. So we've also organized these according to the objectives. The first objective is to characterize the system. And we've divided this into 3 types of systems: a single port, a port network, and an inland waterway. And we've gathered resources to help people identify key stakeholder groups, decisions and objectives, the functions, and the critical infrastructure systems for each of these. And we provide those resources in an appendix, which looks kind of like this. And I know you can't see it too well, but these are some resources that you could potentially use to characterize your system. And we've given the name, the type of resource, the description of it, some important caveats you may need to know. But this is just a way to point people towards what's out there and what's available to characterize the system using a Tier 1 analysis. If I went through all the tiers, this presentation would probably be an hour long. So we're just going to go for the lowest level type of stuff here. The second objective is to identify critical infrastructure and dependencies, which is so important in ports, because one thing goes down and it affects a whole lot of systems around it. So the guide's going to provide an overview of what some of those common dependencies will be, and then what the lifeline services are for infrastructure systems that support a port, like navigable waterways, the terminals, the intermodal connection, and then finally the community around the port. Same deal, there's also resources out there that help you identify critical infrastructure. A lot of these things are resources that the Department of Homeland Security uses for ongoing resilience assessments called RRAPs, the Regional Resilience Assessment Program. Objective number 3, this is the one that's probably most familiar to people, is to understand the impacts to disruptive events. And those sorts of things are existing tools like sea level rise viewers, safety assessments, landslide hazard programs, things that are available online that can quickly show you what's going on in your area. And then finally, we're outlining available resources for doing a resilience assessment. We thought that wouldn't be complete unless we showed some examples of resilience assessments that are ongoing that are using these types of resources. So we have 3. One, Craig Phillip is involved with in Vanderbilt, and I'll walk through them right now. The first is a Bayesian network analysis at the Port of Portland, which is an inland river port. They're really interested to understand the ability of the Port of Portland to provide a federal staging area and to move cargo after a Cascadia subduction zone event in the area. So if anyone is familiar with the Cascadia subduction zone earthquake, it would be extremely destructive to the region. And the question is whether or not the port could play a strong role in providing the movement of goods and services for recovery. So the Port of Portland wanted this study to be done on Terminal 6, which is located on the Columbia. And we're essentially, this is a Tier 3 study where it's very data intensive. And the idea is to create a digital twin of that port terminal, to test it with a Cascadia subduction zone, and then to adjust it based on different mitigation strategies. And you can see how those adjustments might affect the resilience of that terminal. So in the end, the goal is to provide the port with a list of options for potential upgrades, resilience upgrades, which may help them in the future to apply for funding to do this. The second study is a study on the petroleum supply chain within the Tennessee and Cumberland rivers. This is a very important system where petroleum is provided to some of those major metropolitan areas, like Nashville, for example. And inland waterways are unique in the way that they have a non-redundant and linear topography. So it's important to really understand what it means when the inland waterway is shut down, and also reciprocally here, how the inland waterway supports other modes of transportation in the area, like pipeline movements. And finally, the last case study I'll explain for now, although there's so many that are ongoing, not just within our two agencies, but outside as well, is an analysis of the marine transportation system network across the entire nation. And the goal here is to understand the structure of how vessels move between domestic ports and to figure out clusters of related ports according to not only vessel movements, but the types of commodities that are found within each. And so to understand the network will also allow us to understand potentially their role in providing redundancy. If a particular port were to go down, can we still get petroleum or other goods and services to a region? So with that, I'll wrap up. These are the names of my co-leads at DHS for this resilience assessment guide, and then the Pionk Task Group reference down below. Thank you.
All right, good morning, everybody. And it was fun to follow the earlier presentations. What I'm going to do is offer a very brief description of the Illinois River system, the way that it provides competition and interacts with the railroad industry, and then also look at the issue of resilience and the way that navigation is of specific importance to resilience in the Illinois basin. Before I begin, though, there's something that's important to understand. The U.S. and Canada are probably the only two places in the world where the private sector controls the rail side and the inland navigation is provided by the public sector. And that interaction between private and public leads to some very interesting policy questions, and we'll get to those. Specifically, we want to look at 5 things. I'll give a brief system description, look at the way that the waterway contributes to the Illinois economy, look at the nature and extent of railroad competition, and you get to some of those interaction questions. And then look at the issue of resilience, and finally take a look at what the future may hold. The system itself is comprised of 383 miles of waterway wholly within Illinois, between Calumet and Grafton. The waterway supports a 9-foot channel, and it does so through the operation of 8 locks and dams. Currently, 6 of those locks and dams are receiving extensive repairs and upgrades, and in fact, the waterway is closed at this point. The annual tonnage that's moved on the Illinois is 65.5 million tons, or at least was in 2017, but these numbers need some caveats. A significant portion of that tonnage is contained in the Chicago Area Waterway System, or CAWS. And then also there's the data that were used here include a lot of coal movements, which probably will not exist in the future. So we'll focus probably more on the lower system and the agricultural uses. Beyond the cause, and there's a whole entire separate discussion on the Chicago area. Below the cause, and for most of the length of the waterway system, the use is primarily agricultural. Based on the tonnage that goes to LaGrange, which is the lowest lock, the one that's closest to St. Louis, there are about 10 million tons of downbound grain each year and 4 million tons of upbound fertilizer. The dominant waterway connections are to the Louisiana Gulf and to Texas. Some waterway segments have a very dispersed set of origin-destination pairs. In the case of the Illinois waterway, That's not the case. It's really just a conduit between Illinois and the Gulf. For agriculture, and again, this excludes what happens in the Chicago area. For ag shippers entirely, the annual savings are estimated at roughly $500 million a year. Those are direct transportation savings. They don't include the indirect savings to other users, and again, they also don't include the savings to cause users. Janie Camp at Vanderbilt did a series of what we are calling string graphs that show tonnages in specific corridors. And this just illustrates how concentrated the traffic is between the Illinois River system and the Gulf. Again, the Illinois system is a really, really good example of the way that private sector railroads and public sector navigation interact. Where navigation is available, it has an inherent and indisputable cost advantage. So that shipments that occur from origins or destinations that are very near the waterway are going to move on the waterway. However, as you move away from the waterway, users will incur truck costs to connect to the river, so that at some point there's a balance between the rail cost at a specific origin or destination and the combined truck and barge cost. And that generally determines which modal combination is used. Traditionally, that distance has been between 50 and 100 miles, so that shipments, depending on the commodity and its value, shipments that are at 100 miles away from the waterway will go by rail. There is, however, anecdotal suggestion that that distance is increasing. A lot of that has to do with the railroad use of what is called precision scheduled railroading. And that's caused railroads to do things that perhaps diminish service characteristics, so that that would help explain why that distance has grown. Finally, there's the issue of rail capacity, and that's a real hot button issue among shippers in the Illinois basin. That capacity is broken into three pieces: the terminal capacity of the origin in Illinois, the line haul rail capacity that we connect that origin to then Gulf destinations, and finally the terminal capacity at the Gulf. If we look at the last of those first, railroad capacity at the Gulf is certainly more than adequate. As most of the waterway facilities were built, they were accompanied rail facilities that were built with them. And those rail facilities tend to have good capacity, so that's not an issue. As far as the line haul capacity issue, there are really three elements of that. There's the equipment, the infrastructure, and crew availability. The equipment is not an issue. You can move it. If the rail capacity needs to increase, you can move equipment from other parts of the country to the region fairly readily. The infrastructure, if you were trying to move barge traffic to rail, the infrastructure would be stressed, but probably adaptable so that it could handle the additional traffic. The real issue is the terminal capacity in the Illinois basin. Again, because railroads find it very difficult to compete with barge, they make fewer investments in terminal facilities in the basin. To try and move barge traffic to the rail network would cause massive disruptions in the Illinois basin. Trucks lined up for miles trying to get into rail facilities. This gives you a sense of how the traffic is divided between the modes and where it's going. And as you can see, that Louisiana is dominated by barge. The traffic itself is almost exclusively export. Texas is dominated by rail. And the difference here is that most of that traffic is for domestic use within the region, the Southwest region, and not for export. And finally, We haven't talked about the Pacific Northwest, but that is another alternative origin destination. Again, that's dominated by rail. Most of the traffic between the Illinois Basin and the Pacific Northwest is also aimed for export. Finally, to the topic of the day, resilience. Railroads continue to invest heavily in their network. But part of the way they make that investment effective is to limit the extent of that network so that the network is not nearly as robust as it has been in the past. As Mike talked about, redundancy is an important issue. As you reduce the network's extent, you make redundancy, you limit redundancy, and that affects flexibility and reliance in the face of any sort of unplanned rail network disruption. So that while the investment has been important in creating a really robust network, that network is much smaller than it has been in the past. If you take that into account, maintaining or enhancing barge network capacity may be a very important policy prescription. The railroads invest in the network that will profit their shareholders. That doesn't necessarily take care of the entire public. So that making investments on the public sector side to provide additional resilience in the face of a rail network disruption is really important. Finally, looking to the future. As noted, the Illinois infrastructure on the river is being upgraded, and the upgrades are significant in providing reliability in the future. Automation is likely to affect all modes, truck, rail, and navigation. As automation occurs, and depending on how it occurs, that will change the cost of each mode of transportation and therefore the relative cost, which is likely to shift traffic around from one place to another. Next, there are opportunities for cost sharing, and I think it's notable that Illinois and the users of the Illinois River have really led the way in at least discussing the regional contribution to investments in the waterway system. Whether or not that is something that ever takes place is to be seen, but certainly the Illinois Basin and its users have been really, really out front in being willing to discuss that. And the final issue looking at the future is how international markets may change. Again, a great deal of the production within the Illinois Basin is export grain. To the extent that the demands for that grain change geographically, it'll change the relative importance of each mode and the modal shares. You can boil this down to a really simple word, and that's China. The demands for grain from China have been volatile and are likely to remain volatile. So that's going to move around the export locations and therefore the modal use. And that is all I have. The photo here is of LaGrange, and it's the cover part of a study that was produced by the University of Tennessee in Vanderbilt. If you're interested in looking at what disruptions on the Illinois and Upper Miss would look like, and you want it in detail, you're welcome to pull that study down. Finally, if there are questions and you think that I can be of use, my contact information is provided there. And again, I want to thank everybody for letting me participate.
Well, to my fellow panelists, Mike and Catherine and Mark, thank you so much for joining us this morning virtually, and I believe you're all with us, and we will be opening it up for questions for the next 30 minutes or so. I'll be watching the chat and also for hand raises. and we'll try to direct. Be the tour guide here. I will begin with a couple of questions to offer. Mark, I see your face in the chat in the box, so I'm gonna start with you and build on what you were kind of concluding with about the current state of things on the Illinois River. We're in the middle of our harvest season, of course, and it's hard to overstate how concentrated some of the activity can be around the harvest taking place in a part of the country like Illinois, and seeking to get that done before the river freezes and you can't move the product at all. And we are also in the middle of what, at least my long experience in the inland side, was an unprecedented kind of long-term scheduled closure of the Illinois River. It'd been planned and the schedule established, I think, 2 years ahead of the closure, which I think is just wrapping up. It did address longstanding deferred maintenance on the system. But I guess what I'm going to ask you is did the fact that they planned this closure help or hurt the barge lines and the rail carriers? And if so, which ones? And with a resilience lens, did it help or hurt from that perspective?
My feeling is that planned closures, if they are affected as planned, work pretty well, that the users are fairly adaptive. And in this case, it seems like that's what has happened. It does leave a really narrow window, but it seems like this has worked fairly well. I mean, and Mike's point and yours about the linear, non-redundant part of the or aspects of the waterway are important. But it seems like this closure has worked okay, and it largely comes down to the Corps of Engineers being able to execute what they tell users they're going to be able to do. So, and in this case, it seems like it's worked fairly well.
Thank you, Mark. And Mike, thanks for joining us. And I want to kind of follow up with a question related to this circumstance on the Illinois River and ask you to kind of assess it in terms of the 6-step process, which you identified for our participants a few minutes ago. I think this scheduled closure idea could be considered a resilience enhancing effort. Plan, do, check, act, and you also suggest in your 6-step process that it's important for the users to go about measuring the effectiveness of the resilience measures which they adopt, so that you can have a learning robust system that has self-improvement. So how would you advise the stakeholders in the Illinois River domain to begin to measure what the impact was of their efforts here to have this scheduled closure?
Well, I mean, it goes back to a term that you used before, which is kind of a learning process. You have to learn from experiences with regard to any disruption, whether it be planned or unplanned. And in this particular case, the 6 or 7-step process, the very end of it is called monitor the system, i.e. what really happened and how did it affect your organization and your organizational activities. And that's, if you will, the feedback loop. That's always, every good planning process has a feedback loop. And so that's the learning process. So the real question is, how it affected your organization or how did it affect your service, I think begins at the very beginning, where you have to understand, what your services are and who's connected and what's really important from the supply chain perspective. So if I were folks on the Illinois River and depended on it, and there was a planned or scheduled maintenance of a lock of some sort, and I wanted to know how that was going to affect my organization, and most importantly, how do I put in place strategies over the long term to be able to handle this again in a way that could be perhaps a little bit better than what I just did? I would look at, which parts of my agency or organization were affected by this, who had a role in planning for the strategy to respond to this, how do we interact with the public agencies, the Corps, whatever the case was, and how could we improve that communications? How did this affect our customers? How did this affect what they did in terms of what they were doing? So to me, it's very much an assessment process, a very systematic assessment process that identifies everything that your agency or organization did with respect to this disruption, planned as it was. How did it affect what your organization did and your customers? And I would do a debriefing at the end when it's all said and done, saying, okay, what have we learned? What can we do better? So that the next time around, which there will be at some point another time around, that we are in a better position to be able to improve our agency, organizations' activities, as well as our interaction with others that are really our services depend on.
Great, and let me follow that thread and throw a question to both you and to Mark. The most affected stakeholders probably are the barge lines themselves and the customers of the barge lines. And my experience, and I know Mark's from some of the work we've done together, has been that those folks are notoriously difficult to corral in terms of sharing information about what impacts are. So, Mike, I'm interested in what your experience was in the conducting. I can't remember how many case studies there were in the NCFRP study, but I know you were relying on stakeholders to help. So, how do you motivate that crowd to share information that could inform the next wave of things that need to be done? And Mark, I'll ask you really to respond to the same thing, as you've been involved in studies that try to discern what the impact are on these notoriously private rascals that are in the private sector.
Well, I won't use the term rascals as you do, but I certainly would acknowledge that it's not just the barge operators, and it's not just the customers of the barge operators. We've had challenges, shall we say, when we work with rail companies to understand what they're doing, how they're doing it. Well, how did you respond? Well, we're not talking about that. Well, how did this impact your customers? Well, we're not talking about that. And it's understandable. I completely understand it. So the rascals, as you put it, are not just in the barge industry. It's also in other freight sectors as well. And I guess the way I would respond to that question is that, the assessment process that we developed was really internally oriented, which is I would assume that if you have an internal process, assessment process to learn from experience and then make modifications or changes to your standard operating procedures or policies or even organizational structure, whatever the case is, that's done internally. That's not necessarily information that is shared with others. How you get them to the table with others, whether they be public agencies or with customers or with other carriers, for example, to jointly and collaboratively come up with what really makes sense here is a real challenge. And I think what we have found across the board, not just with inland water, but across the board, is to really identify and illustrate what the overall impacts are, both to the economy, to individual operators, companies, to shippers, to the lives of everyday people when things are disrupted. And once you get to that point, you can start to convince people not necessarily to share their proprietary information. That's just not going to happen. But certainly it allows you to get them to the table to have that conversation and discussion. And I have found with meetings that I have facilitated, for example, that once there and they overcome the worry that they have that they don't want to give away any state secrets, that often some very interesting and useful suggestions come out from that collaboration that could be taken back by them or by other agencies or companies to figure out what they can do differently in the future. So I guess my bottom line is internally, I don't see that as an issue because that internal information, that feedback loop and that 6-step process really is an internal process. The real challenge is the collaboration with other groups, and that one I think is you really have to be able to convey. Someone has to be the convener, obviously, and you have to convey the importance of looking at this collaboratively, not to each individual company and participant, but also what this means more generally to society itself, if you will.
Thank you, Mike and Mark.
Patience, persistence, and professional knowledge. Getting this information is extraordinarily difficult. being patient and persistent are important, and having people that are engaging in the interactions that actually understand moving freight and have had a career doing that is incredibly important. A lot of times we're asking questions of firms that they really aren't able to answer, and we're asking them to dissect costs in ways that they're not used to doing, and so, I mean, to some extent, you just have to be really patient and try and express effectively what it is you want to know.
Thank you, Mark. I have a question which I think would be probably best directed to Catherine. Catherine, are you with us this afternoon?
Yeah, Craig, can you hear me?
Great, I can, thank you. So this is from Robert Kraft. For years, the American Society of Civil Engineers have rated U.S. infrastructure in poor repair and in need of reinvestment. Has the current pandemic and the focus on supply chain resilience caused any movement in U.S. public sector investment in fixing or upgrading our maritime infrastructure? And do you think this will overcome executive and legislative gridlock? And I'll invite our other two panelists to respond to that as well after you share with us, Catherine.
Thanks, Craig. What a question.
Easy question.
Yeah, all in 2 minutes, please. Answer 2 minutes, yeah.
No, I mean, it's perfectly valid. And let me first say, like most researchers do, I caveat that I'm a researcher for the Corps. I don't make our budget policy. And if I did, I'm not sure what would happen, but it certainly would include resilience as a part of it. And actually, I'm doing a detail right now with our asset management group at headquarters to try to understand how we are ranking and rating the condition of our assets and the maintenance needs that we have. So I'm actively trying to get spun up on the process the Corps uses to prioritize investments in their river system assets like locks, dams, levees, all sorts of things. So this is something I think about regularly. And I would say, as a member of the Committee on the Marine Transportation System, I've been hearing a lot of conversation about how COVID has certainly shown that a resilient supply chain is critical. But I think that from a lot of from a navigation perspective, a lot of our infrastructure worked well. It was more of a need to think about the employees and protecting like workplace hazards and things like that. And really, employees are just as an important part of the system as any lock or dam to make sure that they're around and healthy and able to move it. But I don't think that's exactly what this question was asking. I think it was asking more about investment and opportunities for that. I can't answer the question about legislative gridlock, but I can say that there's been a lot of conversations even prior to COVID about including resilience as a requirement for receiving federal funding. For example, MARAD's Port Infrastructure Development Grants has resilience as one of the 6, criteria by which they judge proposals for investment. So it is more and more becoming a part of the conversation. I'm not sure COVID exactly is tracking with funding for resilience investment, but it certainly has highlighted the need for a focus on how to keep these commodities moving.
And if I may as well, it's an interesting question. I've been actually part of more webinars recently on that question in terms of stimulus packages, because I did a study several years ago on the last issue we had, which was the 2010, 11, 12 recession. And then if you remember, there were a lot of stimulus packages then. And so I've been part of international webinars because other countries are thinking the same thing. I think the short answer to the question is no. I don't think COVID itself as a disruption is going to cause this country to rapidly invest in infrastructure. Obviously, it's the secondary impact on the economy that's going to be the issue. And so as was mentioned, there are legislative packages on the infrastructure side of things that I suspect are going to be a part of the normal politics of trying to stimulate an economy, not so much as it relates to COVID. And quite frankly, that all.
I hate to agree so completely with Mike, but I think that he's.
Oh, you've made my day now.
No, I think to the extent that there is any infrastructure impact at all, it's probably going to be on the highway side.
Say a little more about that, Mark.
I think we've encountered some truck size and weight issues that have been revealed by COVID that are going to need to be addressed, and that may have an impact on highway spending. I don't see any direct link to navigation or, for that matter, to the rail industry.
I think we have a question from Crystal France, and I'll ask her if she would like to ask it.
She may be having a problem unmuting.
Okay.
She did put a comment in, though.
Can you read it? Because I'm having trouble finding it.
Sure. It says that I belong to the Propeller Club of Houston. We recently had a webinar about resiliency 2 through the International Propeller Club of Houston. It sounds very interesting.
Okay. Great. Catherine, I want to go back to one comment you made, and you mentioned the CMTS, and I'm not sure that everyone in the audience is familiar with that kind of organizational construct inside the federal government, but I think it might be worth sharing a little bit about that.
Sure, no problem. Acronym queen over here. It requires some explanation. CMTS stands for the U.S. Committee on the Marine Transportation System. Essentially, it is a coordinating body for federal agencies that own, operate, or manage the marine transportation system. So it is, I guess, cabinet level, and there's a lot of folks at the top levels of a lot of our agencies who participate in quarterly coordinating board meetings where they discuss emerging issues around the MTS and identify areas for them to collaborate. And then a lot of work actually gets done within teams that are also interagency. So I co-lead a team with NOAA on the resilience of the marine transportation system. And there's plenty of other ones, including the Arctic, infrastructure investment. There's a new team stood up to talk specifically about COVID. There's a whole lot out there. If you search for the U.S. Committee on the Marine Transportation System, you'll find it.
Great. Thank you.
Craig?
I'm
sorry to interrupt. Crystal was able to put the question in chat.
Okay.
It says, can you see it, or would you want me to read it?
I think let's see. The follow-up to they had a resiliency forum at the Propeller Club of Houston. One company that was featured was Cardenas Power Ships. Even nuclear options came up. How will this affect our resiliency? And I'm not sure our panel is exactly equipped to comment specifically about that. I'd welcome anybody who wants to comment. So, and Robert Kraft has a follow-up question to the earlier one about the funding for waterway infrastructure. Thanks for answering my question. With the pandemic highlighting our human element vulnerabilities in the maritime sector, I wonder if there will be any emphasis on workflow automation with respect to infrastructure investment.
Well, I'll take the first stab at that, and I think that the answer to that is yes. I think across society is not just in terms of maritime and inland water, but I think the experience now, in many cases, and I know this is the case because I have friends and family members who are part of major corporations that are rethinking now the entire workplace idea in terms of where will they be located when they work. And some folks have actually realized that they can work from home now, assuming they can figure out what to do with the kids. And so I think there's going to be a rethinking in terms of in many ways, how work actually occurs. Some will still obviously go to the office or to the plant, whatever the case is. With regard to the substitution effect, which was with regard to how you now manage and perhaps operationalize in a mechanical way, or at least in an information flow way. I do think that we were heading there anyway in terms of automation and robots and drones and you name it. I mean, I think we are heading there. My sense is our experience with COVID is speeding up the process of looking at that in a little bit more interesting way, and perhaps a little bit more serious way. So here's one area, I was mentioned before, I think here's one area where the COVID experience has started to be almost a catalyst for people who weren't thinking about this now to at least start thinking about that. So I think it's a great question from Robert, and my answer to that is yes, I do think that that's going to be a bigger issue as we go forward in inland water, maritime, as well as other sectors.
Well, this makes two in a row. I actually agree with Mike completely, but automation has been an important part of the supply chain process for the last 2 decades. I mean, you can go in large DCs, they don't have lights. They don't need them. The machinery that picks the materials doesn't need lighted facilities. So this has been a big and important part of growing within the supply chain process. COVID probably has hastened that some, but this is where we're going anyway.
Catherine,
I'll add one more example to this, maybe two. At least within our condition assessments and our understanding of how our infrastructure is operating, it has really put a thumb down on the need to marry up and match our data sets and figure out how to do that. And do that quickly. Because not only are we worried about automating and being able to make decisions, not just at the district level that focuses on a particular facility, but also at the division and across the whole nation. So it's really, I think, especially with the deficit that we're dealing with right now, it's really making us think that our timelines for getting these infrastructure investments done are becoming shorter. So we need to really quickly figure out how to make comparisons across larger areas. And the other thing, in a sort of a more specific example, is ERDC had a whole research area called structural health monitoring, where we had outfitted locks with sensors to understand and help inform us about their probability of failure. So that was something that was ongoing for several years before COVID, but to echo what Mike and Mark said, it has hastened at least headquarters' interest in how these sorts of technologies can be used to lessen the burden on our people at those sites.
Catherine, if you can find a way to reconcile the data more effectively, you'll be my hero forever.
Lots and lots of conversations about how hard that is and how long it's going to take.
Mm-hmm.
Catherine, could you speak a little bit about the case studies that were involved in the work that you were leading with PIANC, and perhaps describe what PIANC is and its kind of role in the, especially on the inland international landscape?
Great. Yeah, happy to do that, Craig. So FIONC is a world forum focused on water transport infrastructure, and it's a place that professionals get together to talk about guidance for emerging issues. And one of these emerging issues was resilience, and we started that report on resilience I discussed in my presentation right around 2016, and we just published it. So there was years of volunteer work, and everyone knows how volunteer work goes, that went into putting this together. And it was a really awesome opportunity to learn from international folks about how they're thinking about resilience and approaching it. And I think the best part about the report is some of the case studies that are in there. And you asked about examples, and the first one that comes to mind for me is the Room for Rivers program. We talk about the Netherlands a lot when we talk about resilience. There's a lot of political sway there and funding to invest because 2/3 of the country is like under sea level. So there's a lot that they're doing because the pressure is high. And so Room for Rivers is this idea, okay, so they've got the Rhine, the Scheldt, and I think another river, the Meuse maybe. And their whole idea was to figure out how they can increase natural water storage for floods. And they identified through a huge collaboration of governments and regions, even between different countries, some options for doing this. And there are actually like 39 projects that were completed under this Room for Rivers program. And some of that was even taken up, some of these concepts were taken up in Belgium for Belgium's Sigma plan, which looked at the Scheldt River waterway and the whole watershed there. So and I think that one was almost 20 different projects. And the whole goal was to evaluate options for controlled flood areas and how to do that. So when you're thinking about flooding and inland river issues, right there within those two projects are 50 projects that we can take a look at to see what's worked and what hasn't in terms of controlling flooding and making places for water to go. There's also other issues that we focused on, not necessarily episodic flooding, but long-term things like drought. In 2015, the Rhine was at, I think almost a whole year, the Rhine was at 50% of its normal water level. So that long-term, long-duration event resulted in a lot of work that had to be done to figure out how to get around issues like that. They tried reducing the cargo that's moving through the Rhine. I should mention this is important because it connects Rotterdam and a lot of the coastal ports with the inland manufacturing in Germany. So there's a lot of commodities that move on the Rhine. They tried to reduce cargo loads. They tried to go faster between warehouses, and all of those options ended up evaporating as the water levels got lower. So what they found was that the intermodal connections even more important for most commodities. Some things like petroleum wasn't able to move, so it just sat on the river for months until it was able to move again. But after that year, they expanded some of their planning and management horizons for shipping to include road and rail, so that shippers have better decision making to increase the redundancy of those supply chains. So yeah, there's tons to learn as far as what's happening, and those are just European examples. So check out the report.
Thank you, Catherine. And I think we are coming up on our appointed hour to complete this panel. And I don't know if there are any concluding comments from our host for today, but if not, Mark and Mike and Catherine, thank you so much for participating with us this morning. I hope you'll have a chance to see some of the rest of the correspondence. And with that, we'll call this a wrap.